Hello, everybody. My name is Dan Mance. I'm CEO of the Robotics Education and Competition Foundation. Thanks for having me at this wonderful conference. The REC Foundation is a huge supporter of NTMA. We really think that what we're trying to achieve is very much aligned, and I was so excited to have the opportunity to speak this morning. Today we're going to talk about workforce readiness, what it means to the REC Foundation, as well as some of our programs that we've implemented to support it. My hope is that maybe I can share a little bit of insight of what we project the workforce to look like in the future, but also maybe provide some opportunities for you, NTMA community, to get involved in some of these programs to make sure that we have the staff, the employees, the people that we need to be competitive in the next Industry 4.0, and to make sure that our students are prepared to compete at a global level. So first, a little bit about the REC Foundation. Our mission is to increase student interest and involvement in STEM by engaging students in hands-on, affordable, and sustainable robotics engineering programs. So we use multiple platforms. The one we're most known for is the VEX Robotics competition, but we also have drones and other programs to achieve our mission. But basically what we're trying to do is we want to empower students. You know, a couple years ago, we took a step back and we looked at our vision and we said, what do we really see as our vision? And we talked a lot about it. And we have a new vision that we've been loving to communicate to the community, because we see a future where students design and innovate as part of a team, but they experience failure and then they persevere and they embrace STEM. So for us, the experiencing failure is really, really important. It's easy in so many things to build something and say it works and then move on. But in our programs, through the design process, we encourage students to build, but then compete. And often when they compete, matter of fact, I wouldn't say often, almost all the time when they compete, it doesn't go as planned, right? So with our program, as part of the design process, they go back to their engineering design notebooks. They talk about, what went well, but also what they can improve on. It's called reflections, right? They reflect and then they make changes. And we think that failure and then persevering from the failure really develops the type of students that are really needed in the workforce. So our vision reflects that. But basically, we want our programs to develop students so that they thrive. And we think that process of the design iteration is really, really important. So what is workforce readiness? It's interesting, if you go out to the web and you actually Google what is workforce readiness, which I did to prepare today, there really isn't a clear-cut answer, a definition of what it is. So basically what we at the REC Foundation define as workforce readiness, it means that students are prepared to enter the workforce by having the knowledge, skills, abilities, and attributes so they can engage in activities that are required in the workforce. So when I say students, I put an asterisk next to this because it's not just about students. There's many, many other types of workforce readiness out there now. A good example is veterans returning from their active duty, whether they've been stationed overseas or even in the US. There's programs now for inmates being rehabilitated. We consider those all workforce readiness programs, but the focus at the REC Foundation is primarily students. But basically, we're trying to prepare these students to enter the workforce. So as you know, workforce readiness skills are really important because they make sure that students or anybody, the workers, have the basic academic, critical thinking, and personal skills necessary to maintain their employment. Right now, academic skills are often defined as reading, writing, basic math, communication skills. And we agree, but we actually think that academic skills are so much more now. Actually, I'll show the next slide to kind of emphasize that. So the skills that we feel are needed for workforce readiness include what we call the soft skills. And there's 4 C's. There's a terminology going out now, right? 4 C's. And we believe in those 4 C's. Critical thinking, creativity, collaboration, and communication. And just a quick definition, critical thinking, that's finding solutions to problems. And that's what our entire program is based on, is critical thinking. At the beginning of any of our challenges, whether it's VEX Robotics or drones or any other program, we give a challenge to the students and they need to be able to think how they're going to solve that challenge. Creativity. The most successful teams in our programs are the students that take a creative approach to solving these problems. So I think one thing when you work with young people today, it's impressive how creative they are, how they really look at things differently, and we need that in the workforce. We need that to be competitive. Collaboration. When I asked people what they need from students and what we need here at the REC Foundation, the 2 skills that come up most are collaboration and communication. we can teach the tech skills, let's be honest. So many of you are business owners, or you run factories, or you run manufacturing facilities, and you know you can teach people how to use the machines. You can teach them how to do paperwork. But what you really want is people that can communicate right from the beginning. And you also want to make sure that you have a workforce that can collaborate and work together. So those are two of the C's that we really think are important for the future workforce. So why are we doing all this? Well, I'm sure many of you heard the statistic from the U.S. Department of Labor, but nearly 7 million STEM jobs are going unfulfilled. So even when we have unemployment rate, our need for skilled workers way exceeds what we have available on the market. So what we're doing at the REC Foundations is we're providing a pathway to these STEM careers. Sometimes many of our students will pursue a 4-year degree in STEM. That's science, technology, engineering, math. We have so many people in our program that get engineering degrees or become scientists or technicians. But we realized 4 years ago that a large part of our student population isn't going to go to get a 4-year degree. Maybe it's resources, maybe it's aptitude, maybe they just don't have the background coming out of high school, or maybe they just don't have the interest. So we think there's alternate pathways, and one of those is having workforce-ready students. So what we try to do at the REC Foundation is prepare these students with the skills that they don't have to necessarily go to college, but they can get an internship, they can get an apprenticeship, they can go get industry certifications from leading manufacturers, or even go to a trade tech school and get some skills. So the pathway is more than just STEM, it's also workforce development. One of the statistics I most love about the REC Foundation is that students in our programs earn their manufacturing industry certifications 50% faster than other students. That's half the time. So when they have a background in our program, they're ready to earn those industry certifications, and they're ready for jobs in the factories. And I think that's really good. And these are not manual labor jobs either. These are the people that are running the conveyors. These are the robot operators. Those are the robot programmers. These are the high-skilled jobs that don't necessarily require a 4-year degree, but do require an advanced skill set. And that's what our programs are doing. STEM growth. So I think this is a statistic that's widely quoted now. We've had it in our slide deck for the last couple years, but projected STEM growth is 13% for STEM jobs, but only 9% for non-STEM jobs. So of course there's still going to be retail jobs, there's still going to be service jobs, but STEM jobs are far outpacing non-STEM jobs. So it's really important that we commit to giving our students the opportunity to get these skills. So what is the REC Foundation Workforce Readiness? Well, we have a STEM continuum. That's pre-K through post-secondary. What people don't know about the REC Foundation programs is that we do the whole gambit of education. So students can start in our programs as early as kindergarten with basic build and programming. And as they progress through the school years, our programs get more more challenging, I would say. So you might start with basic building and programming, but by the time you're in high school, you're constructing and designing and CADing. We also have university programs. We've got VexU, which is very similar to our high school program, but in this case, the students use a lot more custom manufacturing, 3D printing, and they actually control 2 robots versus 1. And we also have our new AI competition, which is you program both robots and then it's hands-off. And you use sensors and GPS and cameras, and that's a great advanced program for our university students. And we have advanced high school students doing it too. So we have the full spectrum. Our foundation programs, besides the AI program I just talked about, include our factory automation program. This is a brand new program we launched last year. Myself, I come from robotics. I was a roboticist for 20 years at Fanuc Robotics. I started as a controls engineer. I worked as a program manager, and before I came to the REC Foundation, I was a senior director in product development, leading mechanical and electrical development. So I'm a roboticist, and we always knew that mobile robotics appeals to a certain set of students, but not everybody. So we launched our drones program for another subset of students, but our new factory automation program really shows students another path to get into robotics as a career pathway, and I have a few more slides about that. Student resources. We realize that for our students to be successful, they need resources. So if they're pursuing a college education, we have tens of millions of dollars in scholarships available through hundreds of partner organizations. But there's also a pathway called industry certifications where students will actually get in a certificate in either robotics or in pre-engineering. Many of our students get internships, and that's one of the programs that's really growing where the REC Foundation matches students to companies such as organizations and NTMA and make sure that they have opportunities. And then, of course, we have our very strong alumni network. These are the students that so many of our sponsors want to hire, right? They've come through our program, they've gotten either their certifications or they've gotten their 2 or 4 year degrees, and these are the students that ends up having really successful. So we'll talk a little bit more about this in detail. Industry 4.0. Industry 4.0 is a term we hear a lot about, but not a lot of people define it. So from my perspective, if this is, if we were interactive here, if this was a live presentation, we'd probably have a discussion just on that. But we think it's a new phase of the industrial revolution that focuses on interconnectivity, automation, machine learning, and real-time data. For us, that's what Industry 4.0. And I'm actually going to advance a little bit and just go through, what industry, the previous phases. So Industry 1.0 is that mechanism, steam power. That's when people went from using animals and manual labor to starting to use real machines to be more productive. And I think most of us, we think of the big steam power locomotives and machines and stuff like that. The weaving loom is a really good example. So throughputs went up. Industry 2.0. All of us think about Henry Ford. I think most of us know Henry Ford didn't invent the automobile, but he's the one who brought mass production to the automobile. But he wasn't the first to do mass production, but probably the most famous innovator in that area. But assembly lines, bringing electricity into factories for the first time, that was the industrial revolution that we think of. That's Industry 2.0. Industry 3.0 started in my lifetime, and that's where automation, that's my background, is automation as a controls engineer, but that's where computers and electronics really started making things more efficient. I'll remember my first time in a factory. I was 21 years old, and we had photo IDs, and so people couldn't get in the booth. And one of those photo IDs was not aligned, and my first job was to why couldn't this conveyor run? And it was aligning those photo IDs, and that automation and that computers and electronics made it safer for our workers and also made productivity higher. And now we're in Industry 4.0, which is the Internet of Things. It's factory automation, it's artificial intelligence, and that's where we are today. So again, there's current trends of automation. I went back to the previous slide, and one of the things in Industry 4.0 is cyber physical systems. And I think most of us, if we think of cyber physical systems, we're talking about robotics, right? Robotics, advanced conveyors. Those are good examples of where computers and mechanical equipment are working together. That's, smart machines. And then we have the Internet of Things, and that's, Internet of Things has multiple definitions, but that's where basically sensors are embedded now into hardware. And Internet of Things, there's a lot of factory connotations to those, and we can talk about sensors and making sure things are lined up and color matching and not having to have everything perfect because the sensors are going to find and detect. But I actually like the best example of Internet of Things to me is smart homes. And so when I'm describing it, I tell everybody that yes, on your iPhone, or excuse me, your smartphone, you can say, I'll be home in 20 minutes, turn up the heat or turn down the AC, start turning on the oven so it's ready to pop something in. That's the smart devices that we have in our homes. So there's many examples of the Internet of Things, but that's a good one. Cloud computing, when I started my career, you did all your processing on your computer. I remember when we'd compile programs or we'd compile CAD, you hit the start button and you go and have coffee, or you might go to lunch, and that you hoped you didn't have any errors. But now so much of the processing is done in the cloud. And that's really revolutionized because now you can be on your computer, you can do the quote heavy lifting on the cloud, and you can continue to do stuff. And allows us to really crunch a lot more data. And to me, that leads into the fourth one, which is artificial intelligence. There's lots of different definitions of artificial intelligence, but to me, AI is all about using sensors and cameras and stuff to crunch data and to do predictive analysis so that we make more informed decisions. And AI isn't going to be just for manufacturing. That's where it's thought of, but AI will be every part of our life in the Industry 4.0 model. So that's kind of the REC Foundation's definition of what Industry 4.0. And when we make decisions, when we look at what we want to do for our students, those are some of the parameters we're looking at to make sure students coming from our program have knowledge in these areas. So again, cloud computing, they're compiling. They can compile on their desktop, but they can compile on the web. Artificial intelligence, we've got programs dedicated to that, but even in our basic robotics competitions, we now have cameras and sensors, and you compile that data to make decisions. And of course, the interconnectivity of things. You can drive robots now using tablets, and then of course it all comes together with smart machines. And so that's how we're trying to prepare our student base. So our programs, just for the sake of time, we have classroom programs with Robotics Curriculum. The nice thing about the REC Foundation is all those resources are free. So we have an extensive knowledge base that was developed by Vex Robotics that we have access to. And my favorite knowledge base article is actually about gears. It shows how gears work and how you calculate torque and select your gears and stuff like that. It's just one of many, many examples. But we have knowledge base articles on programming, electronics, of course, mechanical, how to build different drivetrains, etc. And we also have what's STEM labs, and they walk you through the process. So curriculum is very, very important to workforce development, and we provide those resources. Of course, there's the hands-on learning part, which is what is most important to me. I love hands-on learning. I think that's how we reinforce the concepts, and again, that's what our robotics competitions do. Is you can learn about gear ratios, you can learn about drivetrains, you can learn about programming, but when you have to put it all together, and that's design and build your robot and then compete, that hands-on learning reinforces it. And then again, our students are very sought after, and they earn those industry certifications, and they're sought for those internships that we've talked about. So that's some of our programs and what we do. Specifically, we talked about having K through career, and our pre-K, the program that we're promoting right now is VEX 123, which is really a really easy way to learn structured programming. Matter of fact, I think it's the perfect programming curriculum to teach adults, that have never done programming, because basically you have a little hardware device and you put cards in there that says move forward or turn left, turn right. So it teaches that concept of structured thinking and programming. In elementary, we have our new VEX Go program. Super excited about that. It reminds me of my youth where we built stuff. So with VEX Go, you build mechanisms, you can build cars, you can build a little robot, factory robot, and you really understand the concepts. You swap out gears, you swap out lengths, and you learn about torque and physics. It's probably the best way to learn physics I've ever seen. And then when you've got those concepts down, you add power. But it's not programming, it's basically a battery pack with an on-off switch and motors. So now all of a sudden you're adding motors to your contraptions to see how they work. And when you have those concepts down, then all of a sudden you add programming. And there's full educator resources behind this program, so teachers can easily integrate it into their curriculum. But that's one of our elementary, and of course our long-standing VEX IQ, which is going on its 10th year now, is, in my opinion, the best elementary program out there, because it's a perfect mix of easy building, programming, with lots of sensors and lots of unique challenges. By middle school, we still support our VEX IQ challenge, but we also introduce drones through our aerial drones program, and this is more of about flying and programming. And then in high school, we get the more advanced robotics. That's where it's kind of like an erector set, right? They're metal parts, they're more sensors, they're more powerful motors. You're connected to the computer to start and stop. It's a much more challenging. Again, in the elementary and middle schools, the students are competing, but they're more collaborating. So you're working with another set of students to achieve a goal, right? The highest score or do a task. But by the time high school, you're actually competing, and so you're competing against students with other students. It's also in high school where we introduce the factory automation competition and our AI program. And then by the time you get to college, again, I touched it, but we have our VEX-U program, our AI competition, and our factory automation. So we got a lot of different programs out there to get students workforce ready. So V5 Workcell, Dylan, a colleague from the REC Foundation, will be doing a full session on the Workcell coming up. I'm not going to go into too much detail. But the background on this is I've been with the REC Foundation for 4 years now. And as we said earlier, we knew that mobile robotics are fantastic, but there's students that wasn't interesting to them. And again, with my background at FANUC and the great resources that VEX had, we really had this vision of bringing a scalable and affordable factory automation program to students. And we were fortunate to get a grant through ARM, which I know NTMA belongs to ARM, but that's Advanced Robotics and Manufacturing. We were fortunate enough to get a grant that was funded by the Department of Defense, and we developed this program. And in this program, it's basically a starting point or a progression for students to learn about industrial automation and learn about robotics. And basically, you build a small little 5-axis robot, and technically the 5th axis is a magnet for the wrist, but it still simulates a 5-axis robot, and you build conveyor systems, and you learn robotics electronics, you learn motors and sensors, and you learn components, and you learn the Internet of Things, because you have to make sure that your conveyor talks to your robot. So we developed this primarily for career and technical education. It's been on the market a couple months now, and the responses we've been getting for it is overwhelming. And we're really hopeful that the NTMA community will support this. I have this vision that the smallest organizations in NTMA will buy a couple Workcell kits for their students in their local schools, and the larger organizations will sponsor an entire school. And they'll get the kits, and then they'll compete in the REC Foundation Factory Automation Competition. So right here is a 2-minute video that kind of explains what V5 Workcell is. And so I'm going to take a pause right now while the video plays.
The current skills gap in manufacturing is projected to lead to hundreds of thousands of unfilled jobs in the upcoming years. Manufacturers are planning on spending billions of dollars to help fill this gap, as these unfilled jobs constitute a significant barrier to growth and the adoption of new technologies. These jobs are not what many assume when they think of manufacturing jobs. Many of these jobs are clean, involve working with high-tech equipment, including robotics, and have the potential to be lucrative. Therefore, while this skills gap is a challenge, it also presents opportunities. The VEX V5 Workcell is an approachable and affordable solution for educational institutions looking to equip students with the in-demand knowledge and skills of today's and tomorrow's economies. The REC Foundation's Factory Automation Competition is a classroom-based competition that allows students from across the world to integrate and recognize how STEM skills translate to the workforce. This unique new manufacturing competition will attract students into robotics manufacturing careers while providing curriculum, resources, and hands-on problem-solving skills. VEX Robotics has leveraged our 5th-generation robotics platform, VEX V5, to the task of automation robotics, using the wealth of robotics electronics, motors, sensors, mechanical, and motion components. We developed the Workcell specifically for career and technical education. Tied in with our successful VEX Code programming software and STEM labs, all students can successfully learn factory automation. The benefits of the VEX V5 Workcell go beyond job training. The collaborative, hands-on approach to the VEX V5 Workcell can enrich the educational experience of all students. Additionally, the integration of science, technology, engineering, and math to solve problems will help prepare them for collegiate work and, of course, for a full-time job. Get started with the VEX V5 Workcell today.
So I hope you enjoyed that video. Again, it's really impressive what VEX was able to develop with the support of the REC Foundation. Again, we were so excited to get that grant and develop this program, and I think it's going to be a big difference maker. This is a statistic I talked about earlier, but since it's my favorite statistic in the REC Foundation, I'm going to say it again. But the VEX Robotics students earn manufacturing industry certifications 50% faster than other students. So That was through our VEX Robotics Competition program, but I think it easily applies to Workcell. And when you watch Dylan's segment, you're going to see some of the incredible STEM labs that we've developed. My favorite STEM lab, I love them all, but one of my favorites is how we teach the coordinate system. So when I started at FANUC, it took me a while to grasp the coordinate system, and I see when factories, most large factories have robotics, but as robotics go to tier 2 and tier 3, that's kind of like a foreign language. It's like hearing French or Spanish or Russian, that whole coordinate system. And it's not an easy concept to grab. But our STEM lab that teaches the coordinate system using this little small VEX robot is really ingenious. And again, that's why we see it as a progression. But again, we believe that this program is really teaching those 21st century skills. Right here, we're going to skip through this today, but if you go to our roboticseducation.org or the VEX site, we have a couple neat clips that show our classroom program doing palletizing compared to a FANUC robot doing palletizing. But for brevity, I'm not going to show it today, but you can really see that we mimicked that factory experience. So I talked about that the REC Foundation actually got the grant for the factory automation competition, and that's what we strove for at the beginning. But of course, we needed a hardware partner, which was VEX, to develop the hardware, and they did it based on their V5. But after you do the curriculum, after you go through the 12 STEM labs, it's all capped off with a competition. And this is not where you travel and go to another school or go out of state. This is an in-class competition. And it's all about throughput, right? So you try to stack, one of the challenges is stack the discs by color as fast as you can. So it's a combination of how fast do you make it move versus accuracy, right? But basically the students through the factory automation competition, they learn their industry, manufacturing, and workforce skills. They learn collaborative project-based learning in an industry setting, right? It's what we think it's going to do is, like, people have kind of frowned on factory jobs. There's this old feeling that factory jobs are dangerous and dirty and boring, dingy and repetitive. So we're trying to make factory automation fun. And by students doing this in high school through their CTE curriculum or at community colleges, they're like, I can do this. And now they're willing to go out there into the workforce and take these robotics jobs where maybe they were intimidated before. And then again, we feel that this program bridges the gap between the classroom and the workforce, and it's actually fueling the innovators for Industry 4.0. So one of the programs that the REC Foundation doesn't talk a lot about is our industry certification program, and it's one of the things that we do to prepare students. So in my feeling is that the student resources that we really need are industry certifications, micro-credentials, internships, and apprenticeships. So industry certifications is where you get training, hands-on training, or educational training, and you earn a certificate that says you're competent in this technology. And the REC Foundation has one for pre-engineering and robotics, and we hope to add more. Micro-credentials are when you show specific skills. And we partnered with Carnegie Mellon Robotics Academy, and they have a great micro-credentialing program. There's many colleges out there that are starting them, but that's when you show expertise in a certain level, such as programming or wiring motors or building a chassis, for example. And we feel that helps prepare students. Of course, there's internships. That's where students in high school or college, they work for a company for a period, typically during the summer or over Christmas break. And then there's our apprenticeships. And people ask me what I think is the most important and the best way to develop a workforce, and I always say apprenticeships. It truly is, but of course apprenticeships are really expensive, right? So we feel by combining industry certifications and micro-credentials, you get that baseline skill set up, and then they take some internships, and then they can enter apprenticeships. But the apprenticeships have been around forever, right? Apprenticeships for blacksmiths way back in the day, and we need apprenticeships to continue today. But we feel that between these four things, we've really prepared our students. So again, I talked a lot about our industry certification, but they're geared for any of our students, and anybody in our program should be able to earn this. You do partner with your academic school. You need to have at least Algebra 2.0, some level of math, but then you'll be able to pass the test. The other thing is we need to make sure that our students do have the opportunity to get that secondary education. So we offer lots of scholarships, and we encourage the community that have students going into colleges to be aware of the scholarships. There's tons of money out there. You just need to look. So next step, do you want to learn more about the REC Foundation? Do you want to learn more about our programs? So contact your parents, teacher, school, and let them know, hey, I heard this guy from the REC Foundation today called Dan. He showed us this really cool robotics competition, or he showed us this factory automation, and I think you should check it out. You can always sign up for our newsletter or follow us on social media. And of course, the first thing you could always go to is our website, which is roboticseducation.org. And that's got tons of resources, including all our free resources. But most importantly, when you go to support, we have a map there. And when you click on that map, it shows every state in the United States. And when you click on one of those states, it introduces you to your regional support manager. So we have support for all 70 countries, including countries actually that don't have VEX robotics programs yet. But within the US, we have a regional support manager assigned for every state, and they're a great first contact. But again, you can always go to our website or follow us on social media. So again, we are located, I guess I should have started with this, but we're located outside of Dallas. It takes us about an hour to get to the Dallas-Fort Worth airport from where we're located. So we're a little bit northeast, but we're a Dallas, North Texas community. And here's our contact information if you were yet nodded off on my last little slide. And with that, thank you. We've chosen to have an interactive Q&A. So once this video is over, I'm going to be available to answer your questions. I'm super excited, again, about the partnership between the REC Foundation and NTMA. And I think together our organizations can really make a positive impact on the students coming up. And not everybody needs a four-year college degree, but everybody does need these skills. And I think our organizations are uniquely qualified to really make an impact on the next generation. So again, I'm available for Q&A, and thank you so much for your time.